Hi, so in this one we are going to focus on thinking recursively. So far when we've been programming, we've been thinking just in terms of if-else and loops and all that kind of stuff. But recursion is another tool, and it's a very weird tool. So we have to think about how we can solve problems with recursion. Now, recursion is not usually the most efficient way, but it is very simple to write, and it's very quick to write. So I'm going to delete all this stuff. Let's, let me see. Ah, yes. Okay. First things first. I'm going to discuss the components of a recursive function. Okay. So here in its entirety is our recursive function. I'm just going to call this f of x, right, of some input. This is our function. And in this function, we need a couple of things to make this a recursive function. Of course, we're going to need the recursive call. Actually, I'm going to use this. We have the recursive call, which is where you actually call the function inside of itself. All right, I'll make this a little bigger. Recursive call. That's where you call the function inside of itself. Now, the issue in the last video is that this is all we had, and it just went on forever. So the other thing that we need is a base case. And what this means is this is when the recursion stops. Okay? This is the final piece, right? Recursive call keeps calling itself until it hits the base case. It goes and stops here, and then we go all the way back up. That's what recursion does. Okay, so and then we also need our logic. All right. So this is what you need in order to make a recursive function. I'm gonna make this a little smaller. So let's think about how we can make a function using these that, let's make a function recursively that prints every number starting from 1 and going up to our number. Actually, no. Let's starting from some number all the way down to 1. Okay. This has to print, let's say we pass in 10. So I'm going to just create the function. Public static void count down. And this is going to take some int n. And in here, we want to print every number from n all the way down to 1. So you could do this with a loop. You could set up a loop and say for int I equals n, or you could even just use a while loop. While n is greater than or equals to 1, print n, subtract n by 1. Right? We could do while, let's see, n is greater than 1, greater than or equal to 1, print line, n, and n minus minus. This will give us what we want, right? So say I call count down with 10. We got count down with 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, makes sense. Now, we can do this without a loop. And in fact, we can do this with recursion, which is what I'm going to show you. So what is the logic that we need, right? What is the base case and what is the recursive call? So the base case, let's think about how we can break this into the smallest little chunks. Okay, the smallest little chunk possible. What is the very last thing that we need to do? What's the smallest little chunk? Smallest. The very last smallest chunk is to print number 1. This is the last thing that we do, and this is also a small chunk. So a chunk of this function could be print some number. I'm just going to do print some number, right? And then we print that number minus 1. And this is the logic that we need. Take a look at this. I'm going to scoot this down here. Take a look at this. We print some number, and then we print that number minus 1. Now we print one number less than this, right? And then one number less than this, and then one number less than this, until we hit 1. This is the same kind of logic that was in the while loop, but in a different way, right? So we can think of this function where we print the number as the initial function call, right? So that's just saying f of x. That's saying countdown of 10. We print the first number, right? So let's print line, right? And we'll print n. Awesome. So now what we have to do is we have to print that number minus 1. Oops, I just opened Ableton Live. That's okay. Hopefully that doesn't script the recording. Let me actually task manager that. Task manager, get out of here, please. Thank you, not responding. Get out of here. All right. So now we have to print the number that we passed in minus 1, right? So what we could do is we could say print line n minus 1. But then we have to do n minus 2, n minus 3, and n minus 4. And we don't want to do that. So instead, notice how I drew this as its own box. What if, instead of creating more code to do the same thing that we already did, we just call countdown with the number we passed in to this function, minus 1. That's it. Okay? Except for one thing, we don't have the base case, but this is it, right? This will do this. Now our function is this, which includes this and this and this, right? Let's follow this line by line. I'm going to run this, and it's going to print out a bunch of numbers and then error because there's no base case. It will never stop, and then it kills itself, right? It says, nope, we're not doing that operation anymore. Boop, right? Alrighty. So let's walk through this step by step. So we start at main. We get to countdown with the number 10. We jump down to the countdown function with n equal to 10. We print out whatever n is, which is 10. So we printed out 10. Then we call the same function, but with the number that was passed in minus 1. So since n is 10, n minus 1 is 9. So now we jump up here, and we call the function with n equal to 9. And so we print out 9, and then we call countdown with n minus 1, which n is 9, so now we call countdown with 8. And so we hop back up here, n is now 8, and then we print 8 out and come down to here. N is 8, minus 1 is 7, and we call it with 7, print it out, call it with 6, 6, print out 6, call it with 5, print out 5, call it with 4. I'm sorry, print out 4. Oh my gosh, print out 5, call it with 4. It's 4. Print out 4, call it with 4. Oh my god, call it with 3. It's 3. Print out 3, call it with 2. It's 2. Print out 2, call it with 1. Print out 1, or it is 1. Print out 1, call it with 0. It's 0. Print out 0, call it with minus 1, and so on and so on and so on. And it will do that infinitely, which is why the thread gets killed. It kills. It says, no, we're not doing this anymore. We're not doing this anymore. So we have, let me scroll back up here. We have the recursive call. We have our logic, right? Recursive call is this part, and our logic is printed out and pass in n minus 1. But now we need the stopper, okay? We need the thing that stops this. And the base case is right here, all the way down to 1. So, if the number we passed in if n is greater than 1 or equal to 1, actually, let me see. No, if n is greater than 1, we're going to print the number and count down, right? Count down again. But otherwise, we're just going to print out, else. We're just going to print out the number and not call it again, right? As soon as n is 2, it's going to print out 2, then call countdown with 1. Now n is 1. 1 is not greater than 1, so it just prints 1, and that's it. We go 10, 9, 8, 7, 6, 5, 4, 3, 2. All of those, we're doing these, the if, and then we get to 1, and that runs the else and stops it. So I'm going to hit run. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Bada bing, bada boom. Excellent. Okay. This is thinking recursively. What you do is this is notoriously hard, by the way. This is like ridiculous how complex this is in comparison to the other stuff. The other stuff is very straightforward. This one is like, you have to twist your brain all around in these weird knots, and like, the thing is itself, but then it's not, and that's okay if you don't get it. It'll come in time. The best thing you can do is to do it, right? Think about how you can break a problem down into n and n minus 1. What will happen is then n minus 1 is itself n, which does n minus 1, which is itself n minus, which is itself n, right? And then n minus 1, and so on and so on. It goes all the way down, right? Ask me in class if you need some help, okay? Good luck. The stuff on coding rooms is not super bad. It's just redoing other projects we've done before, but with recursion. So hopefully this has been useful. Good luck on the assignments.